Hello students, welcome to online video lecture of Computer Organization and Architecture course. Today's topic for discussion is bit pair recording technique of multiplication. So let us start with the session. In this technique, we are going to discuss three important steps. I have taken very simple example to make you understand the bit pair recording technique. So in the example you can see the multiplicand is minus 15 and multiplier is plus 10. Binary representation of minus 15 is written here. So this is the 2's complement representation of minus 15. Multiplier is again represented by using 5 bits. Let us start with the first step. In the first step, you have to attach 0 to the right of the least significant bit of multiplier. So we are having multiplier is 0, 1, 0, 1, 0. So right of this least significant bit, I have attached 0. So the first step is finished. In the second step, you have to create a recorded multiplier by using this recorded multiplier bit table. So in this, you have to follow the two steps. In the very first step, you have to create the pair of 3 bits starting from left significant bit, and if last pair requires extra bit, then you can simply extend the most significant. And in the second step, you have to use this recording table to identify the recorded bits. So first we simply form the pair of 3 bits starting from less significant bit of multiplier. So this would be the first pair, this would be the second pair, and this would be the third pair. Now our multiplier is of only 6 bits. One extra bit is required to make the pair. In the last pair I need one extra bit. So I have extended this 0 to form the pair. Now I have to use this recording table to identify the bits. So this 0 will be considered as ith bit. This would be considered as I minus 1 bit, and this one will be considered as I plus 1 bit. So let us check 100. For pair 100, I must have to take minus 2 as a recorded bit. For 101, I have to take minus 1 as a recorded multiplier bit. And for 001, so 001, I must have to take plus 1 as a recorded multiplier bit. So we ended with step number 2. Let us move to the next step, step number 3. So here I must have to understand 3 important steps, some rules. The very first rule is if the recorded multiplier bit is minus 1, I must have to take the 2's complement of multiplicand as a partial product. And if recorded multiplier bit is plus 1, here I have to take multiplicand as a partial product. If recorded multiplier bit is minus 2, then I have to take 2's complement of multiplicand, and then I have to multiply by 1 0. If in the fourth case plus 2, if recorded multiplier bit is plus 2, then I have to multiplicand by 1 0. So I have demonstrated 3 different cases here. This is the case for if recorded multiplier bit is minus 1 in our example. Multiplicand is minus 15. So I must have to take the 2's complement of multiplicand as a partial product. So I have to convert it into complement form. First I have to take 1's complement. It's very simple. I have to only convert the one. If there is a 1 bit, I have to take 0, and if there is a 0, I have to take 1. After that, I have to add 1 to the least significant bit of 1's complement form. 0 plus 1 is 1, 1, 1, 1, and 0. So this binary pattern is taken as partial product if multiplier bit is minus 1. This case demonstrate if the multiplier bit is minus 2. Here, in this case, I have to take 2's complement of multiplicand and I have to again multiply by 1 0. So already we calculated 2's complement of multiplicand, which is 0 and 4 times 1. Now I have to multiply by 1 0. After multiplying by 1 0, 0, 1, 1, 1 and again 0, I am getting this binary pattern. In the case of plus 2, in the case of plus 2, this is the case of plus 4. I have to simply multiply by multiplicand 1 0 here. So 0 plus 1, so here 0, 1, 0, 0, 0 and 1. This final pattern is taken as a partial product if multiplied with is plus 2. Now let us go for the actual multiplication. So multiplicand is minus 15, multiplier is now recorded multiplier. So in the first iteration I am multiplying by minus 2. So here I have to take this result, this binary pattern as a partial product, which was already calculated in the previous steps. Step 0, 1, 1, 1 and again 0, and the rest of the 4 bits are extended with sign, most significantly 0, 0, 0 and again 0. In the second iteration, I'm multiplying by minus 1, so I have to take 2's complement of multiplication, which was already calculated in the previous step. Here in the second iteration, I have to keep two spaces blank, and the result is written here is partial product 1, 1, 1, 1 and again 0. And the rest of the 3 bits are extended with sign extension 0, 0, 0. In the third iteration, I am multiplying by plus 1. So here I am keeping 4 spaces blank according to this technique. And last bit is again extended with most significant bit, which is 1. So let us make the addition. So here in the first column only one bit is there, so 0. Again 1, 1. 1 plus 1 0 and carry is 1. So 1 plus 1 plus 1, it is in decimal I can write it down 3. So binary I can take 1, 1. So this one is taken as sum and this one is taken as the carry. So 1. Again 1 plus 1 plus 1 plus 1. So this is 4 times 1. So 4 times 1 means I can simply write it down in binary as 1 0 0. So this 0 is taken as sum and remaining 2 bits are taken as a subsequent carry. So here 0 is sum and 1 0 is taken as a carry. So 0 plus 1 1 1 0 1 and 1. So this binary pattern is nothing but the product of minus 15 and plus 10, and as the result is minus 150. So this result is basically the 2's complement of 150, because negative number is represented in 2's complement form. Let us cross check the result. Let me represent this minus 150 in 2's complement form. First, I have to take the one binary pattern of 150. So 128 plus 16 plus 4 plus 2, so it becomes 150. As the product size is of 10 bits, so I am taking 2 extra bits here. First, I have to take 1's complement 1, 0 is taken as 1, 1 is taken as 0, and finally 0 is taken as 1. And I have to add 1 to the least significant bit of this 1's complement. So 1 plus 1 0, carry 1, 1, and again 0, 1, 1, 1, 1, and this is the 1. So here the result is exactly similar to the what we got in this multiplication. Thanks for watching the video.